mute Nakajibi. Okay, thank you, Silver sir. And so we may start the session right now, or we should wait for a few minutes for some other. Okay, okay, thank you very much. Okay, thanks. So, so let me start. So, I think that screen is very clear to everyone, and my voice is also clear to everyone. So, let me start. So, this is today is the fourth day for our session on MCS 227. So this is our fourth day session on the MCS 227. So in the beginning of the MCS 227, the cloud computing and the IoT, we already have seen that we have two sections here, two here in this MCS 227. One is your cloud computing and another portion is your Internet of Things. We already have discussed in the last few sessions about the cloud computing and the various aspects and the topics which is being covered in your blog. Today, we are going to start the blog 3, which basically discuss about the IoT, Internet of Things. So here in this blog, we will discuss about the Internet of Things, its basic terminologies, the introduction, and then we will discuss some kind of the protocol involved for the IoT. So let us start the block 3 for the Internet of Things here. So let us proceed. Uh, okay. So Internet of Things. So what is the Internet of Things? The first things come in our mind that what is Internet of Things? In general, in typical word, Internet of Things basically relate to the connection of all things, sharing of the data and the sharing of the data and the information using internet by the things. Things may be any object, any product or any object that is sharing the information using the internet. So for an example, suppose that there is an air conditioning device in your home, and presently you are at your office and you wish to control the switching on or off your AC, the air conditioning device. So if your AC is enabled with the IoT technology, then you may easily handle the functionality of the air conditioning which is in your home by sitting in your office. So Internet of Things, the two words are here, Internet and the things. Things basically referred all kind of the object or the things which is internet enabled. So internet enabled means the control information, the data, and the other information can be sent to the particular things, and as per the instruction, definitely the things will react accordingly. So things means anything which is connected with the internet, each fall under the category of Internet of Things. So the Internet of Things, it required a very vast interconnected physical devices. Physical devices, it may be anything. The physical devices may be anything. It may be your vehicles, may be your home appliances, and any kind of the object which is embedded with some kind of the sensors, softwares, and the connectivity to collect and exchange the data. By the example we have seen that if you wish to control the air conditioning device, so the air conditioning device has some kind of the capabilities, some kind of the sensing devices, and this particular device is sensing the environment, sensing the temperature of the room, and accordingly it reacts. If the temperature is high, you have set the some temperature. If the temperature is maintained by the air conditioning up to your predefined temperature, then the air conditioning will automatically cut off. It will stop the cooling. So there is just some sensors, some devices, some sensors which basically monitoring your room temperature. And as soon as the room temperature achieve to the desired temperature, then this will automatically cut off. And it is sensing the temperature. If the temperature reach beyond the predefined temperature point, then it will again start the cooling. So the Internet of Things devices, these devices having some kind of the embedded, this kind of the objects or the devices is embedded with the sensors, software, and the connectivity. Sensor basically sense the environment. Software basically do some kind of the action based on the sensed data, and the connectivity technology allow to send the information to some other point. So that is the Internet of Things. So now the devices from everyday consumer products, like any kind of the consumer products, like your smart thermostats, wearable fitness trackers, home assistants, to the complex industrial machineries in the manufacturing, healthcare equipment, infrastructure, everywhere you will find the IoT devices. So IoT devices basically connect the devices, analyze the data, and generate in a real time and utilize insight to improve the efficiency. So these Internet of IoT devices basically used to connect with the nearby IoT devices, generate the environmental data, and later on we analyze the data to generate the real time result, and accordingly we may take some proper action. So the characteristics of the IoT is your, so following are the characteristics of the IoT, and the IoT is contributing to widespread adoption and the application of various industries. Everywhere nowadays, you may find the IoT enabled devices, IoT devices everywhere in nearby, eh, every aspect of the society. So you can see here that these are the following characteristics. The first characteristic is your connectivity. So IoT devices are connected through the internet. Internet is the one major role. It is playing a one major role because the devices which is connected with the IoT, or the devices which is having the devices which is IoT enabled, they must communicate using the internet. So you can communicate with the internet, or device may connect to the another device. Device may communicate with the other device as well through the internet of the internet technology. So by the involvement of the internet, a seamless communication and the data exchange between the devices, systems, and the users are going on. So data communication, it may be the users, it may be the IoT device, or it may be another devices as well. So each IoT device is having some kind of the sensing and the monitoring equipments, some kind of the sensing and the monitoring equipments attached here. So sensing equipment basically sense the environment, enable them to monitor and gather the real-time information about various conditions. So IoT devices are particularly being used. If we talk about the industrial applications, so IoT devices are being used to those locations where either the human involvement is not feasible, or to the particular location to the uh, health issue. So in that places we may put up the IoT devices for the sensing and the monitoring the equipments. Similarly, the next characteristic is processing. Data processing basically collect the locally data and transmit it to the some centralized system for. So we may have two kind of the IoT, two kind of the IoT categories here. In the first category, the IoT device itself collect the data and transmit it to the centralized system. And we have another kind of the IoT devices collect the data, but it will not analyze. It will not do any kind of the analysis or the analysis by other elements. Either the device itself analyze the result, or some kind of the devices which may just only collect the information, collect the data, and put to the some centralized system where the analysis or the control will be done. Another characteristic is your automation and the control. So allow for the automation and the control. As we have seen with the example of the IoT devices, you can switch on or off your device in your home by you sitting in your office. So from your office, by your smartphone, you may easily control the functionality of the air conditioner far away from your location. Similarly, the scalability, it is accommodating a vast number of the devices and the user. So the scalability is the another characteristic of the IoT devices. Scalability basically refer to the enabling or accommodating lot of devices, not only the air condition. Nowadays, every kind of the smart devices, like your air conditioning, like your light bulb, like your refrigerator, like your washing machine. So any kind of the home appliances, all kind of the home appliances nowadays are coming with IoT integration. So the another so other characteristics are interoperability, security and the privacy, energy efficient, dynamic and self-adapting, self-configuring, unique identity integrated into the information. Unique identity means because the devices are communicating using the internet. So every this kind of the home appliances devices or the devices which is IoT enabled, having some kind of the unique identity, just like your IP address, etc. So technology that made available, so made IoT possible. So the technology accessibility to the cost-effective, energy-efficient sensor technology we have, that is broadening the potential for IoT implementation beyond computer manufacturing. So accessibility to the cost-efficient, energy-effective sensor technology Similarly, the internet connectivity is the another important component which basically play a very major role in IoT devices. Internet connectivity here to much easier way is being available to the customer. So most of the customers nowadays are connected with they are connected with internet. So internet connectivity play a very important role in the IoT development. Similarly, the proliferation of the cloud computing and so we already have seen cloud computing are basically used to store the information or used to access the infrastructure which is not available to you. So by the IoT devices, the data, the IoT devices basically sensing the environment and it creates the data, and that data need to store some centralized location for the further access. So the cloud computing platform here also providing one of the back support to the IoT devices to gather and send the sense data to the some central location for managing the entire system, etc. Progress in the machine learning and the analytics coupled with the extensive data repository stored in the cloud empower business to simply glean valuable insight from the so the we have seen the advanced technology like machine learning and the cloud computing, which basically help us the large amount of data to perform to analyze the data for IoT devices. Some more advanced technologies like convolutional neural networks and natural language processing. It also helps the IoT devices to perform in better way. So IoT categories. So IoT devices can be categorized into the various categories based on based on their working principle. Mostly based on the devices which are being used in a particular domain. So the first category which is being discussed is the IoT devices, which are basically designed for the consumer applications. All the devices which are designed for the consumer application having the are the IoT enabled fall under the category of consumer IoT. So all IoT enabled consumer appliances are falling under the consumer IoT, and these devices include the smartphones, tablets, sensors, wearables, devices which connect to the internet using the Wi-Fi technology or the Bluetooth or the Zigbee technology. So this technology offer the short range communication suitable for the deployment in the smaller area like your home, etc. So this consumer IoT having the numerous use cases for the commercial IoT, including monitoring of the environmental condition, managing across to the corporate facilities, in economizing the utilities and the consumption in the hotel, etc., etc. So consumer IoT having lot of applications. So you may apply to the any kind of the area where the monitoring is required. So there you may place the consumer IoT devices. Another category of the IoT device is your industrial IoT. So industrial IoT, it is the short form is IIoT. The industrial IoT basically refers to those kind of the IoT enabled devices which are designed for the industrial application, industrial usage. For an example, so industries like your healthcare, agriculture, automotive, and the logistics are basically using the IoT devices. For an example, in the agriculture, you may see the drone, the IoT enabled drone, which are being used for spreading the fertilizers and the pesticide over the crops to control the insects, etc. So these are the example of industrial IoT. Similarly, in the infrastructure IoT, it includes so infrastructure IoT uh, basically consider those kind of the IoT enabled devices which are being used for the infrastructure development, smart infrastructure development to boost the efficiency, cost saving, and the maintenance. So it basically include the monitoring and the controlling of the operation of utilities, farms, etc. So which are IoT enabled and basically used for the infrastructure development and operation fall under the category of industrial IoT. Similarly, the Internet of Military of the Things. So all kind of the devices, IoT inner devices, which are being used in for the military operation, military purpose, that fall under the category of Internet of Military of Things. So, mm, like military settings and the battlefield situations, like your ballistic risk assessment, including the response times, common IOMT applications include your connecting the ships, planes, tanks, soldiers, drones, etc., to make a controlling and monitoring of the battlefield. Similarly, the retail IoT basically utilized for the inventory management, personalized shoppings, customer behavior analytics, etc. etc. Similarly, we have an environmental IoT, which basically used to monitor the quality of air quality, water quality, climate conditions, etc. etc. So all IoT devices are equipped with the sensors and some kind of the actuators and some kind of the software and the internet. Obviously, the internet is the one of the important component of the IoT devices. So IoT devices are basically designed to sense the information, sense the environment, generate the data, and send the data to the some centralized location. So enable so IoT enables and the connectivity layers. So if we see about the IoT enablers and the connectivity devices, so the IoT devices are empowered to make the informed decision that drive for favorable business outcomes, etc., etc. As the pressure of the cost and time to the market exceeds, sensors offer enhanced visibility into the internet connection. Nowadays, we have some more advanced sensors and which which basically sense the environment, sense the environment very accurately. So sensor play a pivotal role in furnishing the actionable insight that fuel the IoT. So sensor devices basically sense the environment and sense the environment and send this data to the some centralized location for the further processing. So IoT enables sensors devices. So devices sensors are basically used to monitor to analyze the environment. So this is the one of the IoT enablers devices. Another devices are your Wi-Fi because the IoT means that things are connected with the internet. And in order to use the internet, you need some kind of the device which basically facilitate to connect with the internet. So Wi-Fi is one of the major role-playing component which basically allow us to connect with the internet. So this basically tailored for this Wi-Fi or the 4G LTE wireless devices like smartphone, portable devices, etc. etc. are the one of the another key player for the IoT enablers. So we have another kind of the IoT enablers, IoT sensors, uh, IoT driving the development for the numerous 5G communication, etc. etc. So baseline technology. So now we have to discuss about that. The whatever the IoT devices are there, what are the components basically in the IoT devices? Let us discuss the component of the IoT devices. So the foundation of the IoT the foundation of the IoT built upon the several key technology that enable for the connectivity, data processing, and the communication. So the one of the major component of the IoT technology is your sensor and the actuators. Sensors are a kind of component embedded in the IoT devices, which basically monitor the physical world, which basically sense the physical world, like sense the physical world and perform action based on the received instruction. Actuators. So sensors and the actuators, they are two components. Sensors basically sense the physical world, sense the environment, and accordingly, the actuators is the component which basically reacts as per the sensor data. For an example, if your air conditioner, you have set your air conditioner temperature up to the temperatures, suppose that 20 degrees Celsius. We have set the air conditioning to cool down your room temperature up to the 20 degrees Celsius. As soon as by the some time, as soon as the room temperature is being maintained at the 20 degree, you may observe that suddenly your AC is stop working. AC is stop cooling the room, cooling the room. So who has told the air condition to stop this one? The sensors has generated the data that the 20-degree temperature is now maintained. Now the sensors send this information to the actuators, and the actuators basically activate here and stop and stop the cooling down facility of the air conditioning device. So similarly, we have a lot of kind of the sensors as well as the actuators, like the sensors like your temperature sensor, motion sensor, light sensors, etc., etc., and some kind of the actuators like your opening of valve, turning on a motors, etc., etc. So, for an example, IoT-enabled devices by the mobile, you have sent your an instruction to your motor car to start this one. So, so the sensors has since the information that since your information your request, and the sensors send this information to the actuators to activate the car. Similarly, the connectivity technology, we have a lots of connectivity technology, and all these technology are basically refer to the protocols, the network protocols, which enable it to the send the information like your Wi-Fi, Bluetooth, Zigbee, connect connect with the another IoT devices or with the single servers. The cloud computing is another component of the IoT device, which basically allow us to store and process data by the sensor for the IoT devices. So IoT device is suppose that you have placed a CCTV camera, IoT enabled CCTV camera in your home for the monitoring for the monitoring purpose. So you have placed a CCTV uh, uh, camera in your home. The IoT enabled the CCTV camera in your home. So this CCTV camera is now capturing all the images of your home and send it to the some particular location, because this images or the information need to be stored somewhere for future analysis. So where it will store? So if you have placed the CCTV camera in your home, then and in order to store the information of the CCTV footage, you need some kind of the storage space. So you may place the you need to purchase a storage space in your you need to purchase the storage space. So so in order to purchase the storage space, you have to invest lot of amount here. So alternatively, we have seen with the help of the cloud computing, during the discussion of the cloud computing, we have seen that if I need some kind of the services without procuring the infrastructure, then we may go with the cloud computing. So on the clouds, I will create an account. I will take a cloud service from the cloud service provider, and this CCTV camera will directly store the footage on the particular storage devices under the cloud computing. So the cloud computing play an important role for the IoT devices to store the information future analysis. Similarly, the edge computing, cloud computing is a very vast thing, and the edge computing is the sub-component of the cloud computing. So, cloud computing referring to the one large infrastructure, whereas the edge computing is the part of the sub part of the cloud computing, which having the smaller infrastructure in comparison to the cloud computing. It has some smaller infrastructure, and the edge computers are more closer to the user in comparison with the cloud computers. So cloud computers basically reduce edge computers, edge computing basically reduce the latency and hinder data processing closer to the source. Next one is the security technology. So we have various security technology like your encryption protocols, authentication methods, firewalls, secure device management, etc. The some example of the security technology. Machine learning and the AI. So the ML and the AI the machine learning and the AI technology basically help us to monitor, analyze the gathered data by the IoT devices. So IoT devices is gathering, monitoring, and gathering the data, generate the data, and these data are saved somewhere in the cloud. And now this data need to be analysis for any kind of the prediction or come to the some point of conclusion. So what we may do, we may here basically we may apply some kind of a machine learning and the AI tools to analyze the data. Next is IoT analytics. The IoT business model will exploit the information collected by the things and demand a new analytics tools available. So it is not compulsory or mandatory that the data that has been collected right now or within last 1 day or the 2 day, that only will analyze. After analysis of the 2 day data, this data are still being available with the storage devices either in the cloud device or your personal storage devices. After 1 years, you may need a data of a particular day. So you may go back and you can take the data for the further analysis. So IoT device management. So long life, non-trivial things will require management and the monitoring, including the device damage and the software damage. Obviously, so IoT device management is another important factor for the IoT devices. Similarly, we require low power short range IoT networks because the IoT devices are placed nearby. IoT is in your home. You have a IoT enabled light. You have a IoT enabled washing machine. You have a IoT enabled the refrigerator. You have a IoT enabled smart TV. You have IoT enabled some kind of these home appliances. So all these home appliances are not placed very far away from each other. So you do not need a sophisticated internet connectivity devices to connect these small devices. Otherwise, you have to pay a larger amount here. So what we may do, we may go with the some kind of the short range connectivity technology, like short range connectivity technology, like your Bluetooth, like your Wi-Fi, like your uh, radio signals in your devices. So the IoT connectivity so low power short range networks will dominate the wireless IoT connectivity by the 2025. IoT processors. Now the IoT devices having the another component that is the processing power. Processing power, that is the processor or the microprocessor. So these microprocessor, or you may say about the microcontrollers here. So these microprocessors require a very sophisticated, very high speed microprocessor. You need a small kind of the microprocessor, is basically, uh, which is basically a sensor will sense the data, and this data will be sent to the processor for the processing, and the processor will send this data to the cloud for the large processing. So IoT processors are capable of IoT processors are very small enough, and they are capable for strong security and the encryption, less power consumption, and sophisticated enough to support an operating system syntax. So IoT processors are not if you are placing very high speed processor here, then definitely power consumption will one of the major issue. Another thing is that IoT devices, basically, we have discussed about the IoT devices, IoT enable the home appliances. Now, there are other monitoring devices IoT monitoring, IoT enable the monitoring devices that like your CCTV camera, like your drones, etc. So in this kind of the devices, so in this kind of the devices, what we have a very high capacity processor. Such kind of processor is enough to maintain the IoT functionality. Similarly, for the IoT operating system, we do not require a traditional operating system, very traditional, very costlier, and the too bulky operating systems like Windows or iOS. It is not required. We have a tiny operating system, TINY, tiny OS. We have a tiny operating system that having basic functionality to support the IoT function, and it also having a feature of guaranteed real-time response. Similarly, event stream processing. So some IoT application will generate extremely high data rates that must be analyzed in the real time, just like that in the data which is being running by the aeroplane, or the data which is being sent by the running a railway or train. So you need to analyze the data in the real time. In the real time, the aeroplane is sending the data to the some center, and at the centers in the real time, this data need to be analysis for the further decision making about the aeroplane. So IoT standard and the ecosystem, so standard and their associated application APIs will help us to interoperate and communicate with the many IoT business models. These are the some kind of the IoT IoT technology, IoT basic technology we have. Now we have to discuss about the components of the IoT. So the one of the major component of the IoT is your sensor. Sensor is a kind of embedded device. Sensor is a kind of the embedded device which basically monitor the environment where the particular sensor has been designed, like your temperature sensor. So temperature sensor will monitor the temperature. It will monitor the temperature throughout the day. Similarly, so sensor attain a physical parameters and convert into the signal suitable for the processing. So sensors, so temperature sensors has sense that the present temperature of the room is 35 degrees Celsius. So this information will be converted into the signal, and that signal need to be transferred to the some other location. So, so the signal, it may be a electrical signal, mechanical, or the optical signal based on the nature of the sensor. So output of the signal is converted into the human readable form, like your uh, changes in the characteristics, changes in the resistance, capacitance, impedance, etc. The signal level. So characteristic of the sensors. So sensor signal basically correctly represent the nature of the environment after it is stabilized. So you are placing the sensors in the environment, and that sensors will basically stabilize. So once you started the sensors, so it will stabilize in the environment after few seconds, few time, and then it will start its functionality. So important statistic characteristic of the sensors include the sensitivity, resolution, linearity, zero drift, full scale drift, full drift, range, repeatability, and the reproducibility. Let us see one by one these characteristics. So sensitivity. So sensor must have some kind of the sensitivity. Sensitivity means what is the range of this sensitivity? Suppose that you we talk about the temperature sensor. So temperature sensor which are being used in the home, in the general home. So it may have a some range, some predefined range like 0 degrees Celsius to the 5 degrees Celsius. So this may because in the room temperature may be 5 degree, or the system cannot decrease. than the 0 degree Celsius. So like that, we are defining the sensitivity range here. So sensitivity is a measure of the change in the output of the sensor related to the change unit in the input devices. For example, speakers we have purchased for your home entertainment may have a sensitivity of the 1889 dB decibels signal pressure per watt. So that what kind of sensor and every single kind of sensor. What is the sensitivity of the sensor? The sensors ranges from the minus 40 degree to the plus 100 degree and more than that. That kind of the sensors are also available in the market. So you have to choose the promptly. You have to choose those kind of the sensor which is more suitable for your work. Another characteristic of the sensor is the resolution. Resolution means a small amount of the change in the input can be detected and accurately indicated by the sensors. What is, for an example, what is the resolution of an ordinary rulers or ordinary calipers, etc. So basically, resolution is so just like that, the room temperature sensor. So temperature sensor is monitoring the temperature, temperature, and a small amount of the change of the temperature is again being notified to the some central location. Similarly, the linearity is the determine the calibration curve. So static calibration curve plus the output amplitude minus the input amplitude under the static condition, and the degree of the resemblance to the straight line describe the linearity. So linearity basically whatever the input and whatever the output amplitude, input amplitude and the output amplitude, we draw a graph in between of the input amplitude and the output amplitude. And if the line comes here as like a straight line, means the input and the output are calibrated to each other, and they are working perfectly. If the straight line is not coming, it means that definitely the calibration between the input and the output is not up to the mark. We need to recalibrate. So linearity recalibrate the sensors as well. Because drift is a deviation from the specific reading of the sensors in the sensor is kept at the value for the prolonged period of time. So suppose that you have applied a temperature sensor in your room, and this particular sensor and your room temperature is not that. Suppose that you have applied a temperature sensor in your room, and due to some reason there is no change in the temperature of the room for a very long time. Suppose 4 or 5 hours, there are no change in the temperature. Temperature is constant, is being constantly here. So in that situation, the sensor is continuously monitoring and always generating the same kind of the data because there is no change in the environment. So so what will happen here? So you probably so the cloud or the storage device to which it has been calibrated to send the information. That storage device may be that system may be in a confusing state that whether the sensor is still alive or the sensor is sending me the constantly one data only. So, in order to verify the working of the sensors, some kind of a drift required, so that sensor could not be fixed on the prolonged period of the times. So a zero drift refer to the change in the sensor's output if the input is kept steady at a level. So zero drifting will require some kind of the drifting in the signals periodically, so that the sensors may not go for the zero reading. Similarly, so we have a zero drift, we have a full scale drift. So full scale deflection, etc. etc. We have. Range of the sensors, we already have talked about the range of the sensors. It is determined by the allowed lower and the upper limit of input and the output. Repeatability is defined as the deviation between the measurement in a sequence when the object under test is the same and the approaches its same value for the same direction each time. So repeatability. So measurement have to be made under a short enough time duration for the significant long-term delay. Reproducibility. Reproducibility is the same as a repeatability, except it also incorporates long-time lapses between the subsequent measurements. Long-time lapses are also being observed by the reproducibility functionality. So dynamic characteristic of the sensors represent the time response of the sensor system. So dynamic characteristic sensors represent the time response of the sensor system. Delay, it basically how much time it takes to sense the data and send the data. So delay of the sensors. So depending upon the what kind of the applications you may have, what kind of the functions, or what is you supposed to accordingly we have a different kind of the sensor. So sensors like we have various kind of the sensors like your temperature sensor, pressure sensor, motion sensor, some kind of the chambers where the pressure atmospheric pressure, pressure of the stored gas or the liquid in the seal system, tank or the pressure sensor. Similarly, the another kind of the sensor is a motion sensor, and it basically senses the movement of the physical object by using several technology, like your passive infrared technology or the microwave detection, ultrasonic detection. Motion sensor basically the terminology like motion sensor basically monitor the motion of an object. How the motion of the object can be monitored? So it can be monitored by analyzing the previous position of the object and the new position of the object. If there is a difference between the previous position of the object and the previous coordinate of the object and the new coordinate of the object, if there is no difference, means the objects in the steady state. If there is a change in the coordinates, the location coordinates, the coordinates of the same object, sometimes back and right now, then you may easily see that there is some kind of the motion in the object. So this thing is being monitored by the motion sensor. So one is motion sensor. Basically, it takes the help of the passive infrared or the ultrasonic to detect the coordinates of the object. Similarly, the level sensors basically monitor the level of the liquid related to a benchmark value in a system. For an example, fuel tankers or the water tanks and like that. Similarly, some automobiles have a light that illuminates when the fuel level tank is very close to infinity, etc., etc. Like in your vehicles, if you have analog meters, so you can see the needle position, that how much fuel are available in your tank. If you have a digital fuel meters, then these digital fuel meters will show you the some numeric value, or the some kind of the images to uh, to say you the level of the water. Next one is we have our image sensors, basically capturing the image to the digitally stored for the processing, etc. etc. Proximity sensors detect the presence or absence of the object. Proximity sensor basically detecting the presence and the absence of an object. Similarly, we have a water quality sensors. Uh, we have a chemical sensors like oxygen sensors, electrical conductivity sensors, pH level sensors, turbidity levels sensors, etc., etc. So you need to understand the basic working principle, and then you need to design your own sensors as well. Like we have a chemical sensors. So chemical sensors basically detect the presence of a specific chemical in the substance. Similarly, we have a gas sensors. So gas sensors basically detect the presence of the gas. Like we have a bromine sensors, we have a carbon monoxide sensors, we have a chlorine sensors, we have a chlorine dioxide sensors. So we have a different kind of the sensors, specialized sensors to basically sense the any kind of the harmful gas in any kind of the gas in your environment. Similarly, the smoke sensors basically detect the peak and the presence of the smoke condition. So it is basically applied in the uh, area, uh, like your uh, fire monitoring, etc., fire safety check. So we are basically using the smoke sensor. Infrared sensors. So infrared sensors basically detect the infrared radiation that emitted by the object, just like that. In the night vision, in the night, you are in the forest in the night, and you need to observe. You need to monitor that some wild animals are not passing nearby you. So how you will analyze this one? So we may take the help of the infrared sensors, and this infrared sensor based on the body temperature of the moving object or the wild animal. It basically show us the activity of the wild animals nearby, the presence of the wild animals nearby, by analyzing the radiation emitted by the object. Similarly, we have acceleration sensors that basically detect the movement of an object. Acceleration sensors or the accelerometers to detect the rate of the change of the velocity of an object. So we have acceleration sensors basically detect the change of the velocity, the rate of the velocity of a sensor. So actuator is a machine component or system that moves or control the mechanism of the system. So sensors basically sensing the environment, and then it sends the information to the actuators to take the necessary step, as per the sense data. Just like that, we the human body having a lot of sensor. We have we have a lot of inbuilt sensor. So suppose that suddenly you are feeling very cold, or suddenly you are feeling there is a fire nearby to you. So who have told you that there is a fire nearby to you? So your body or your temperature, your sensors, your body sensors are there, and that are smart enough to check the nearby temperature. So suddenly there is a fire nearby to you. So the fire, so your sensors like your eyes can easily capture this one, and accordingly, as soon as you have found that there is a fire nearby to you, so what will happen? So suddenly, so you have seen that there is a fire nearby to you. So suddenly you will stand up and you will start running from there. You will start running from there. So what happened here? The sensor has sensed, your eye has sensed, and the leaves so that you may run away from here. Similarly, suppose that there is a fire, but that fire is not much harmful fire, just like it, a fire of your incense sticks or fire of your match box stick. So by looking at that fire, the the eye has seen the fire, and the eye has sent this fire information to the mind, and the mind will analyze that okay, this fire is not much a harmful fire, so it will not send uh, any kind of the reactive information uh, to your actuators like your leg etc. So the actuators basically perform some kind of the action based on the sense information. So we have a various kind of the actuators like your electric actuators. We have a linear actuators, rotary actuators. So linear actuators produce the linear motion, where the rotary actuators convert the electrical energy into the rotational motion. So you can see here that electrical actuators basically. So electrical signal actuators and the rotary hydraulic linear motion. So this is the working principle of the hydraulic actuators. Similarly, rotary hydraulic actuators so convert the hydraulic power into the rotary motion. So are being used in the heavy duty applications like you're moving heavy loads, steering systems, some type of the extended. Next, we have pneumatic actuators. Pneumatic actuators, we having a pneumatic cylinders used to compress air to create linear motion here. Whereas pneumatic rotary actuators uh, generate a rotary motion using the compressor. In the pneumatic cylinders, we have a very compressed we have very compressed air in the cylinder, and it basically used in the industrial operations like automotive assembly lines, control system, manufacturing systems, etc. Whereas we have a pneumatic rotary actuators. By the name, you can easily understand that there is a rotary inside this one. So rotary is moving. Rotary basically allow a motion in an object. So the rotary actuators are being used in the some kind of the precise equipments where the motion is required. So we have a pneumatic kind of the actuator. So just like that, we have a various kind of the sensors. We have a various kind of as soon as there is something, so it will start rotating. So positioning on the nano positioning sector. Electroactive polymers, so basically change the shape or the size in a response to the electrical signals. So it is being used in the artificial muscles, soft robotics, biometric devices, etc. So uh, so we have a various kind of the actuators as well. So application of the actuators. Now you can easily understand it. What is the application of the actuators? So some of the example of the application and the devices and the types of the actuators are given here. So applications like your automated control of fluid flow in pipelines and the process system. uh, if you are working with the pipeline system, yeah, just like that, water pipeline or the pipeline or the petroleum pipeline. So there is a pipeline system. So and you need to monitor this one. So we have a various kind of the actuators like your pipeline or the process system. So we have a control valve flow monitors. So actuator types is a linear or the rotary, maybe anything. Adjustment of the industrial valve positioning and the machine components. So you can easily understand. So you can see here that there 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 are a lot of application area. We have a we have a few devices, and we have a very few actuator types right now in the market. So this is one of the great challenging area to develop your careers as a researcher and the device management. So positioning of the machine components in automated production systems, this kind of the um, actuators are being used, and these are the some example of the actuators. Transmission of the power in the machines such as conveyor system and the gear pumps. So we have a gearbox actuators, gear pump actuators, hydraulic motor actuators we have. So we have a various kind of the actuators as well. Just like that, we have a various kind of the sensors. At the same times, we have a various kind of the actuators here. Just a minute, just a minute, please. Okay, okay. So now let us. So we have seen about the some IoT devices. We have seen the some IoT components. We have seen about the characteristics of the IoT. We have seen about the components of the IoT like sensors, actuators. We have seen that how the sensors basically work, how the actuators basically work. Do you know the boards? So basically Arduino boards are a kind of the breadboard where you need to place the some kind of the electronic component like your IC, like your motor, like your power devices, like etc etc. So there is a breadboard, and you have to attach these kind of the components in order to develop kind of the IoT device. So if you are very good in the electronic components concepts like your memory concept, like your register concept, like your capacitor concept, let me show you the image. So you can see here that this is the board, and you can see here that there are a lot of components here, like your ICSP pin. This is your microcontroller. This is your preset button. This is your USB for the communication, etc. Voltage regulators are given. Power buttons are given like that way, and we have a various kind of the voltage level here. So if you are very good enough for the electronic component assembly, then you may go with the Arduino board. Similarly, the other alternative is we have a Raspberry Pi. So in order to work in the Arduino board, you must have a clear idea about it, the components, their functionality, and their assembly knowledge. If you are not familiar, you are not very good with the, you are, if you are not very good familiar with the electronics component, then you may go with the Raspberry Pi. So Raspberry Pi is a very cheap computer that runs. So Raspberry Pi is a kind of a device, The size of the Raspberry Pi is near about the size of your ATM card, the debit card or the credit card. So this particular small device, it's work like as a computer. So this Raspberry Pi having the Linux operating system, and you may find one GB of the RAM as well, and there's just some GPIO, general purpose input output pins, where you just insert your sensors, and the Raspberry Pi will start working on. So let me show you. So you can see here that if you see the configuration of the Raspberry Pi, so you can get the GPU as well as the CPU. You will get the CPU, the speed in the 700 megahertz to 1.2 gigahertz speed. You may get the memory, the RAM, 256 MB to 1 GB memory. You may insert the micro SD or the digital SD for storing of the data, or you may directly connect with the cloud computing. So these are the configuration of the Raspberry Pi. So you can see here that this is the Raspberry Pi. So there is a difference. If you see the difference between Arduino and the Raspberry Pi, so in the Arduino you have a breadboard and you need to connect the component here. Whereas in the case of the Raspberry Pi, the component is directly connected with the this is your USB port, so you may connect with the monitor and the keyboard, and you one of your computer is now ready to work. So 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 these are the some introduction of the IoT devices. Now let us discuss about the IoT architecture. So this IoT having the IoT architecture. So the reference model has been introduced by the Cisco and the IBM in 2014 at the IoT World Forum. And according to the official release of the Cisco Forum, the architecture of the IoT aims to help educate CIOs, IIT departments, developer on deployment of the IT chips and accelerate the adoption of the IoT. So layers of the IoTs are just like your if you have studied the computer network, so you may have some kind of the TCP/IP layers, some kind of the ISO OSI layers concept. So these layer concept basically allow us to partition the overall working, which layer will do what kind of the operations like that. So the layering of any communication system make it easy to understand. So similarly, in the IoT devices, we have a four layers: the perception layer, the connectivity layer, the processing layer, and the application layer. So let us start with the perception layer. So perception layer basically converting signal into the data and vice versa. So perception layer is the inner component of the IoT device, and it basically uses the components like your sensors, actuators, devices to uh, sense the signal, to sense the environment and convert into the appropriate signal. Similarly, the connectivity devices, so sensors and the actuators has sensed and it has converted the data. Now this digital or the analog data need to send somewhere else. If the IoT device is connected with the cloud storage device, then the sensed data or the sense or the monitor data will be automatically converted into the IP protocols will not directly work here. You need to modify the TCP or UDP or the IP protocols according. Bilal, you have any doubt?
Mm.
I request Bilal to either you put your doubt or the question, or you may please mute yourself. Mr. Bilal Omar, because your sound is disturbing. So your microphone is disturbing the session here. So either you may please mute yourself, or if you have any kind of the doubt, you wish to discuss something, please discuss here. Uh, okay, I think that Bilal is not listening to us. I may need to continue in this way, or someone else may please point to Bilal that he may mute himself. Okay. Okay. Uh, okay. Now the Bilal button is not muted. I request the admin to kindly mute the Bilal because it is generating some noise. Mute. I request Mr. Bilal Umar, please mute yourself. Your mic is disturbing the session. I request admin or the Sylvester to kindly mute the Bilal.
ايوه شايفه ثورة.
RC Delhi, the meeting host, please mute the participants so that the class may continue. The host, I request host to kindly mute the participant. I request the meeting host to kindly mute participants. Okay, thank you. Okay, so now, so the noise has stopped now. So let us continue with the discussion. So we are discussing about the layering, the connectivity, the layers. Sorry, do you have any question, Bilal? Bilal, do you have any question or doubt? Yeah, sure. Okay, so now, no, still the Bilal is unmute. Uh, okay, okay, thank you for muting the Bilal. So now let us continue. So we have seen about the perception layer. So perception layer. So we have a four layers here. The layering approach is basically designed to uh, designed to work efficiently, designed to work efficiently, and the layering approach enables simple and safe data sharing between two devices over a distance of the 65,000 nodes can be developed and that can be combined to do the work. So similarly, so just like that in the computer networks, you may have gone through the TCP/IP layers and the ISO OSI layers. Similarly, in the IoT devices, we have four layers here. So in the first layer, we have seen about the perception layer. The first layer is known as the perception layers, and the components like your sensors, actuators, machine, and the devices are the part of perception layer. We already have seen that what is the sensors, what is the actuators, and so on. Next one layer is your connectivity layer. So connectivity layers. So we have seen that the sensors is basically sensing the environment, actuators taking some action, and these environment data, these sense data need to communicate with the storage devices or the centralized system where the data may be analysis in future. So this information need to transfer to the some remote location. For that one, we use to go with the connectivity layers and the some standard protocols like your TCP/IP protocols or UDP/IP stack protocols are here to help us to transfer the sense data to the remote location. So just like that, your Ethernet connections, like your the Wi-Fi, like your NFC near field communication. So they are basically used to the another protocols like your Bluetooth, LoWAN, LPWAN, Zigbee, etc. So every this connecting technology having their own advantage and the disadvantage. Some limitations are there, some advantage and disadvantages are there. Just like that, for an example, near field communication enables simple and safe data sharing between two devices over a distance of the 4 inches or the 10 centimeter or this. So this NFC basically enables two devices to communicate with each other. However, the distance restriction is up to the 4 inches only. So, for an example, your smart card, and if it is a NFC enabled a smart card, so you just need to swipe and you just need to uh, cross over. You need to pass over to the NFC readers just by showing your smart card, and it will automatically capture the information. So similarly, we have a Zigbee technology. So Zigbee technology can handle up to the 65,000 nodes. So depend upon different kind of the networks. We have a edge computing. We already have seen for computing. We already have seen in the previous sessions. So connectivity is basically enable the data transmission. The next technology is your uh, next layer is your processing layer. Next layer is your processing layer. So the perception layer basically helped us to monitor the data, and the communication layers helps us to send this data to the some particular location, some remote location, or to the some centralization. Next layer is your processing layers. These processing layers basically accumulates, store, and processes the data. So sensors perception layer has sensed the data, communication layer has transferred the data, and now the processing layer will process the data. So all this, so storing, accumulating, storing, processing, all are commonly handled by the IoT platforms having the two major stage. One is the data accumulation stage. So data accumulation stage with the help of different kind of the APIs, application program interface, at the race to meet the requirement of non-real-time applications. So uh, it may be a real-time applications or it may be non-real-time application. Just like that, monitoring of the data. So monitoring of the data. So temperature sensors is generating the temperature data and it is being sent to the central location. So at that central location, it is being stored somewhere. If there is a huge fluctuation in the temperature, that is a alarming situation. So this data accumulation stage, so basically it receive the data, capture the data, and the API, with the help of the API, we later on analysis the data. So event based data generation and the query based data consumptions, etc., is the part of data accumulation stage. Whereas we have another stage at the processing layer, that is the data abstraction stage. So here the data preparation is finalized to so that the consumer applications can use it to generate insight. So in the data accumulation stage, we are just accumulating the data with the help of the some kind of the API. Whereas in the data abstraction stage, with the help of again some kind of the specialized API, we finally generate some kind of the insight into the data. So combining the data from the different sources, it may be from the both IoT or the non-IoT, or it may be from the different location. We reconcile multiple data format and aggregate data in one place to make it accessible. So similarly, data collected at the application layer is reformatted here for the sending to the physical layer. So at the perception layer, we have generated the data. At the communication layer, we have sent the data, and at the processing layer, we now process the data, and we have an application layer. So we now whatever the data processing we have done, now that after that, whatever the result is coming out. So just like we are coming with the data visualization or the advanced analytics. If you have a data science paper, if you have a data mining paper or the data science paper, if you have gone through that papers, then you can easily understand that after the processing of the data, we basically generate the result in the visualization form. So that is known as the data visualization, etc. So that is basically used for the further purpose, like your business, for the business purposes, for the security purposes, for the device security purposes, etc. So whatever the data has been generated, based on that one, if this data is basically providing you a business opportunity, you can you can go with that one. So depend upon that what kind of the data has been changed, that kind of the application is now being generated here by the application here, and you can utilize that data. So result may be related to the business, related to the security, related to the connectivity, related to the cloud, etc., etc. Now come to the application of the IoT. So now it is clear to everyone that what are the application part of the IoT. So now you can easily assume, you can easily here assume that what are the different kind, what may be the different kind of the IoT applications. So like the IoT wearables. So if you need to monitor the heart rate, if you so your smartwatches, so all these are the your fitness beats, etc. So these are the example of IoT wearable. So those kind of the IoT enabled devices which can be weared at your human body is your IoT wearable devices. Similarly, we have a smart home applications. So we already have seen there are a lot of example for the smart home applications, like your smart TV. So a smart TV, your smart fridge, your smart washing machine. etc. So that can be controlled, that can be that their functionality can be controlled through the internet. Similarly, the IoT application in the healthcare, it is one of the most prominent area of the IoT. So now the healthcare hospitals etc. are now using the IoT devices to monitor the critical illness of the patients. So medical examination, see the data through the analysis, real time, field data testing, etc. are being going to be performed by the IoT application in the healthcare. So just like that, your the CT scanning devices or uh, CT scanning devices or your dialysis machine or your ultrasound machines. So these are the machines which basically monitor the condition of the patient, and these data are being transferred to the some center location or to the desktop of doctors, medical practitioner, and the practitioner by sitting in their room. They are monitoring the patient illness condition, and accordingly they may go for the treatment. Similarly, the smart cities are now being built up, and these smart cities are the core component of the smart cities are the IoT devices, and these IoT devices provides various functionality to the smart cities, like traffic monitoring, optimized traffic monitoring, and the optimized traffic decisions, and etc. etc. Similarly, in the agricultures, there are a lot of applications. So this is the most prominent area where the IoT devices are growing very rapidly. So the statistics estimate that the ever-growing world population to reach nearly 10 billion by the 2050. So in order to feed that much population, we need uh, uh, a smart agriculture technology, like a smart greenhouse are the example of the IoT application in the agricultural part. Similarly, in the industrial automation, wherever we need a monitoring or the controlling, we need a monitoring. There we may easily use the IoT devices like digitization, inventory management, quality control, packaging, logistic. In all these places where you need to deploy some person to monitor, now you can deploy the IoT devices to monitor this one. So challenges of the IoT, security. Security is the one of the challenge. So whenever we talk about the any kind of the communication technology, so as the communication technology basically transferring the data from the one location to the another location, so there is always a chance of data leakage, or there is a chance of the attacks, data attackers, so cyber attackers to steal the data. So security is always a challenge. So it is not true that today you have applied some kind of the security mechanism on your devices, and it may be safe for the throughout lifetime. You have to analyze this after the month or the 2 months, that whatever the security techniques we have imposed on the devices, that is working perfectly, or some new kind of the security challenges has emerged. So so, as the IoT devices also involved in data sensing, monitoring, and sending. Then the security challenges are associated uh, with the data breaches here, security breaches here. Similarly, the regulation challenge, as the IoT devices are being designed by the different companies. So regulatory challenge is coming here. So a few of the countries are developing the IoT devices, and that devices are going to be used by the worldwide. So the whatever the regulatory or the legal or the ethics issue to the one country, it may vary to the country to the country. So the devices which are being generated at the one country, so the device manufacturing company may always assume about the regulatory issue of that particular company. So it is not looking for that for which country they are developing, because at the production level they cannot assume that which country that this devices is going to sell. So the regulatory challenges are there. So generally it lack a specific regulation and the oversight. There is no specific one standard regulation that need to follow. So that is a one of the another challenge here. Compatibility challenge, if the one company has developing the sensor, other company is developing the actuators, next company is developing the communication protocols. So these, so there should be interoperability, the acceptability of the devices from coming from the different manufacturer. That is a one of the compatibility, this is the one of the compatibility challenge. And mostly all these components are, if you are using all these components from the same manufacturer, then it is very easy to combine, very easy to make a communication here. Similarly, the bandwidth challenges, because there is always the devices are connecting with the internet. So the availability of the internet and availability of the bandwidth during the communication is one of the another challenge, especially for the or especially for the urban areas where the communication technology bandwidth are not easily available. Similarly, the another challenge is your customer expectation challenge. So you have imposed some kind of the functionality in the IoT devices, and the customer may have larger expectation from that. So that is always expectation challenge. So you need to redesign, you need to but this is a continuous development process. So you need to redesign, you need to may have so these are the some challenges here. So thank you everyone, and we have completed the unit 8, and tomorrow I will discuss about the unit 9, and tomorrow not about the tomorrow, you may have, you will get some information uh, from the admin that tomorrow may be class or not. So we have one we have last one session left. This is the end of the session today, and we will discuss the unit 9 and the other unit into the next session. So this is the end of the today's session. If anyone having any kind of the doubt, you may please put your doubt. You may unmute yourself. You may please put your doubt, or you may write your question or the discussion topic in the chat box as well. Now, or whatever you wish to discuss from this particular. So I request, if anyone having any doubt, you please put your doubt here, or we will simply end the session here. Okay, there is no any doubt. No one is raising any question. So thank you everyone for attending the session. Thank you everyone for attending the session, and we will meet in the next session for the further discussion. Thank you, Muhammad Abdul. Thank you very much. Thank you everyone for carefully listening and joining the session. We will meet in the next session and the next session will be the last session. So I request everyone to kindly go through the block, all the blocks here given to you. And if there is any kind of the doubt in any part of the block, we may discuss in the next session as well. So I request everyone to kindly go through the block, and if you have any doubt, we may discuss in the next session as well. So thank you everyone. Now I'm going to end up the session. We will meet in the next session. Thank you everyone. Bye bye.